I'm John Hart, and I'm the moderator for this session, Innovative Construction, Stormwater Management, and Transportation Environment. For any questions, please use the chat during the session, and at the end, we'll field as many questions as we can. But it's really my pleasure to introduce Barry Fagan. He'll be presenting right now. Barry is he's a national resource and communicates innovative stormwater management solutions throughout the nation. He guides clients at the intersection of natural and built environments and has done so for the past 30 years. I work with Barry on a couple of state projects. He currently leads the environmental infrastructure group for Volkert. Volkert has 40 offices throughout the nation, where he fulfills part of his personal mission of helping good people get better at managing stormwater. Barry loves dirt, he loves water, and he enjoys the challenge of keeping the two separated. So without further ado, Barry, please.
All right, John, can you hear me and can you see my screen?
Yep, we're good.
Awesome. All right. Hey, everybody. That's how we say aloha in Alabama. I'm Barry, and like you, I'm a stormwater professional. I get to help good people at the intersection of natural and built environments every day of the week, and I love that. I particularly enjoy construction stormwater management, and as John mentioned, I do really enjoy dirt. I enjoy water, and I enjoy keeping the two separated as best I can, and particularly in linear transportation environments. And that's what we're going to talk about today is managing construction stormwater in that linear environment. But I don't want you to think that the lessons and the approaches that we'll talk about today only apply in linear transportation worlds. They don't. I've applied some of these principles and approaches in residential construction and commercial and industrial and even on 1,000-acre, 1,300-acre solar facilities and applied them successfully. So we'll talk more about the application of some of these lessons as we go along. So John mentioned I work with Volkert. We're based in Alabama, but we work where our offices are, say, from Texas to New York to Florida and everything in between within that triangle. That's where our geographic footprint lies, but we do work outside of that. So I've done work with the Ohio DOT and the Nebraska DOT and the Oklahoma DOT, and maybe closest to you guys, the Nevada DOT a few years ago. So my background, I worked for the Alabama Department of Transportation for about 26 years. I retired from there about 4 years ago. And so today I'll share a little bit about that background and my time at AlDOT leading the construction stormwater program. And then we'll talk about a case study that involves a project that was going on while I was there at AlDOT. So most of my career has been in construction as an inspector, as a project engineer, as the assistant state bridge construction engineer for a while, and then the assistant state construction engineer dealing with environmental issues, mainly stormwater. For the last 6 years or so, I worked directly for our chief engineer, really just trying to get folks to talk to each other. Trying to coordinate, and I tell folks that if you complain about a lack of coordination long enough, sooner or later AlDOT will make you a coordinator, and that's kind of what happened to me. I recognize that construction people don't talk to design people, that don't talk to maintenance people, and we were really kind of a siloed bunch at AlDOT, and so I tried to create a culture where it wasn't just the environmental people that cared about the environment. And I remember telling a lot of our construction staff, you don't have to care about the environment. You just have to act like you care about the environment, please. And so we developed this culture of compliance, which sounds good, but it's not. When you're barely checking the boxes, you're really at risk. As you guys know, we don't control how often it rains, how hard it rains, how much rain we get. We don't get to control the types of soils we work in or the steepness of the slopes or even who our neighbors are. And so we've got to build in a lot of cushion and grace into that process if we're going to be successful. And I told folks at out there for a while, if we continue to put off doing right things long enough, sooner or later a regulator will come along, beat us over the head, and make us do it their way. And while I think that's a solid observation, it's really not a good way to run a program, and certainly not appropriate for managing and doing our work in a way that protects this planet that we call home. So I know that several of you are in a similar spot of trying to convince others of the need to manage construction stormwater well. And so I'll share with you a little bit of how I got there. See if I can get my slides to change here. So ALDOT's mission, like most state DOT's mission, was to provide a transportation system for the movement of people and goods within the state. And that's probably true of most state DOTs. And so what you're left with there as far as employees are folks that really didn't sign up to protect the environment. They signed up to design, build, maintain transportation systems. And so one thing that I made it a goal of mine to do and was pretty successful at doing was making a real connection between our mission of providing a transportation system and our responsibilities. And so this is kind of the way I laid it out, and we'll use this framework as we go through the case study later. But I would tell our folks, in order to provide the mission, to provide that transportation system, we have to engage in activities that have the potential to negatively impact the environment. And it's that potential to negatively impact the environment that triggers our environmental responsibilities. And those may be in the form of regulatory requirements and social expectations. You know, our neighbors, the taxpayers of our state, they expect us to behave in a certain way as we do our work. And so we absolutely need those regulatory clearances and authorizations and permits, but we also need the buy-in from our neighbors and taxpayers in order to completely fulfill our mission. If we don't address all of our environmental responsibilities, projects get delayed, projects get halted, funding gets stopped, and so it makes it very difficult to fulfill our mission. So that was somewhat successful in getting transportation folks to have this vision of environmental protection, but it was an evolution, and it was a lot of work. A lot of our progress at ALDOT, and we went from worst to some close to first, maybe. ALDOT has one of the most effective construction stormwater programs in the country that I've been a part of or have worked with or seen. But it took a pretty long evolution of thinking differently and trying to get beyond the way we've always done it. And so a couple of things that we learned along the way were, we started where most successful stormwater programs start, with a good old-fashioned regulatory butt spanking, honestly. And then we started looking at, okay, what is the problem? And like most programs, we saw the problem as sediment. Our sediment in the water, in the river, our sediment in the stream, our sediment in the neighbor's field or church parking lot. And it didn't take us long to realize that sediment is really just a symptom of a bigger problem. And there's really not a way to, on a linear construction project, it's hard to make a sediment trap big enough to manage all the sediment you're generating if that's all you're doing. So we looked toward the source, and we realized that as we gave ourselves some cushion between us and that resource or area to be protected, we were getting closer and closer to the source of the problem. And so we decided that and saw that the more soil particles we could keep up here, the less burden it was to try to catch them down there, if that makes sense. And a lot of programs stop there. They call themselves cultured once they realize that it's erosion and sediment, or sediment and erosion, and not just sediment control that we're trying to achieve here. But we wanted to know more. Here in Alabama, the cause of that erosion is water. It's water flowing to us, it's water landing on the project, and so we developed this mantra of clean water in, clean water out. And we decided it wasn't our responsibility to clean up someone else's water as it flowed through us. It was our responsibility to not add sediment or add pollutants to that water. And so we started diverting water around and under and over and away from our construction site. We saw that it's near impossible to get sediment out of flowing water, but you can get flowing water away from your sediment. And so we started managing water and then realized that, you know, somebody's got to do this for us. We've got to convince our contractors that these are things that are important to us. And we realized that our contractors are capable people. They are smart, they are innovative, they're also willing to do just about anything we ask them to do, as long as we tell them up front and we're willing to pay for it. And I think if you talk to your contractors, or if there are contractors on the call today, I think you would agree, if we tell you what we want and we're willing to pay for it and tell you up front, you can do just about anything we ask you to do. But we have to let you know, we have to tell you along the way. And so at ALDOT, we realized, really later than we should have, a couple of years into this evolution, that communication is the best management practice. And so we work through these, what we call the 5 pillars of construction stormwater management. And those are really in order of priority, they're in order of effectiveness, and they're in an order of economy. You know, if we think about how much it costs to communicate with someone these days, you know, not a big cost, especially when you compare that to some of our practices and products that are intended to capture sediment. And so we walk through those 5 pillars, and I'm not sure exactly how this works, but I did give the conference organizers a couple of handouts. One is a fact sheet on the 5 pillars of construction stormwater management. It kind of lays out each one and gives some examples. And then also shared an article that I wrote for TR News, the magazine or the publication of the Transportation Research Board of the National Academies of Science, Engineering, and Medicine. So those may be available through the conference. If they're not, email me and I'll send those to you directly. I'll be happy to do that. So, so we learned about the 5 pillars. That kind of evolved over time. We also learned a lot about the revised universal soil loss equation. And I had a tendency to get really nerdy with the Russell equation and all those fancy and nice variables. You could plug numbers in and spit out some good information. But at the end of the day, what I learned the most about the Russell equation came from the product, the average annual soil loss from that slope or from that area that you're studying, and it's measured in tons per acre per year. And so what we want is the tons or the mass of sediment to go down. And in order to make that go down, we have to either or both reduce the area of disturbance and or reduce the duration of disturbance. So ask yourself, can we reduce the area of disturbance? Now answer, yes, we can. Can we reduce the duration of disturbance? Yes, we can. But it takes some intent. We have to manage communication and manage work to make that happen. And so, so those are some things going into this case study that I want to talk about now. This is an interstate widening project, and please don't think that this only applies to interstate widening projects. Even if you work for a Department of Transportation, you may not ever get the opportunity to work on an interstate widening project. Just know that this case study does apply to other forms of construction and even other areas of transportation. So this project, you can see we're going to add 2 lanes to a section of Interstate 20, Interstate 59 in Tuscaloosa, Alabama. So Tuscaloosa is the home of the University of Alabama. Any Alabama fans out there? Yeah, me neither. I'm an Auburn graduate. I do appreciate you guys sending the Tagovailoa family to us. I enjoyed watching Tua and his brother play in high school. Well, Tua in college and his brother play in high school here in Alabama. And neat family and absolutely great athletes. But anyway, all that's going on in Tuscaloosa, Alabama. Tuscaloosa is also the home of our former governor, and this project was a priority of his. So we're going to widen to the inside, which is the way we initially widen interstates for the most part. About a 9-mile long project. You can see heavy traffic there, 50,000 vehicles per day, 45% of those trucks. So the interstate looks like this before we get started. This is a typical divided grass median. You probably have these in your state also. This is how it looks on the ground. This is how it looked. This is the cross section from our plan set. Not joking. This is my drawing. So here's kind of the way I see it going into this process. This is where we were at the beginning. This is where we wanted to be. And you guys know that we need some structure. We need some drainage up underneath those cars as we widen to the inside of this interstate. So thinking about this project, and again, we're walking through our mission. We've seen our mission, what we've got to do. These are the activities we have to engage in to get there. We'll talk about impacts and responsibilities later. So in order to fulfill our mission, what's the first thing we have to do to widen this interstate? From the perspective of a stormwater professional, what's the worst thing we can do to widen this interstate? Well, we've got to strip off all that vegetation. So 9 miles of roadway, that's about 60 acres of disturbance. And from that point forward, we are at risk. We are at risk of sediment leaving this project. We don't have a lot of room on the outside within our right of way to capture all this sediment that's trying to leave. We don't control the rain. We don't control the soils. We don't control our neighbors. And so every time it rains, we're at risk of losing sediment from this roadway. So we do a little cutting, a little filling, we compact, we put our drainage in, and this is where it really gets interesting. This is where Barry would get the call and say, hey, Barry, what are we supposed to do now? We've got the regulators on our back, or we've got the water keepers on our back. What do we do? And there's nothing you can do. Even knowing the 5 pillars of construction stormwater management, there's no sediment control to be heard of. You can see a piece of plywood on the end of that pipe. That is a best management practice. That's how we keep heavy particles from getting into that pipe. But we know any water that goes into that pipe is going to be carrying finer particles and is going to be turbid. And so, the best thing we can do at this point is get out of there. Let's get this place covered up and move on. Same with our inlets, the wattles there, those are for show. The best management practice we have available to us here is that open excavated pit. Water goes in, it slows down, fast water meets slow water, so sediment starts to drop out. But we know any water that gets in that inlet is going to be turbid and we're going to have problems. But I don't know what to do about it otherwise. It's just a tough stage of construction. But at some point, we get our drainage in, we get our crushed aggregate on top, and we get to a stabilized state, a somewhat stabilized state. But that takes a while to get there. So on a 9-mile project, maybe that's 8 to 10 months here in Alabama to get to this stabilized state. And again, 8 to 10 months of risk, 60 acres of disturbance. So let's look at our impacts now, and they're obvious: water quality, habitat, private property, regulatory actions, civil actions. Something that was important to me is embarrassment and loss of trust and grace. My job was to keep us out of the newspaper, basically, and certainly keep us out of jail. And I had spent years and years trying to build up trust and grace among our regulators and environmental groups and our other stakeholders. And we know that one mistake, one slip up can erase years of goodwill as we're trying to build that trust and grace. And so those are kind of the potential impacts that trigger our responsibilities. And so on this project, our regulatory requirements were pretty stringent. We had our general permit, but we also had a TMDL because of a receiving water that required this impaired receiving water required a 32% turbidity reduction and a 60.8 NTU limitation. And that's not against background. That is, the water leaving your project had to be less than 60.8 NTU, which you guys know is a tough thing to do, especially if you're working in clay soils. So our social expectation that impaired water that I mentioned earlier is Hurricane Creek. And at one time in the past, Hurricane Creek was completely void of life. It was dead as a result of mining and the steel industry in the area. And now it's coming back to life. It's a beautiful stream. It's got a lot of wildlife and people on it. And so there are a lot of friends of that creek that didn't want Aldott to mess it up. And so you've got the Hurricane Creek Keeper, the Friends of Hurricane Creek, Black Warrior River Keeper. The Hurricane Creek drains to the Black Warrior. And Aldott had made a commitment to, in front of everyone, that it's our goal to protect the environment as we do our work. Now, the Hurricane Creek Keeper, his name's John Wathen, and he's extreme. He's certainly committed to Hurricane Creek, and I'll say that he loves Hurricane Creek almost as much as he hates Aldott, which is a lot. So this is my friend John Wathen here showing his bare back and tattoo to a former president of the United States. That is not a photoshopped image. That came directly out of our state newspaper, AL.com. And I just want to let you know this guy's serious about looking after Hurricane Creek, and he also hates Aldott. So just keep that in the back of your head as one of the responsibilities we have to deal with going forward. So I've been pretty good at making this connection. I think there's logic behind it and people get it. But the question that's haunted me most of my career is, Barry, how do we pull it off? Yeah, it looks great on paper, but how do we do it? And particularly this project. And I was fortunate enough to have to answer that question, that really challenging and hard question on this project. So we're getting ready to let this project contract. Our director gets a letter that says, dear Mr. Cooper, we regret to inform you that this project cannot be let to contract in its current form, basically. And while that letter, we encountered that from time to time from different entities, this letter came from within. So the project was designed in our central office, but our Tuscaloosa office said, no, we cannot meet all of our responsibilities doing it the way we've always done it. You guys have met John Wathen, you know the Hurricane Creek, you know what we're up against, and you've given us the same old process that we've always used, and it's not going to work in our area. And so the director was fuming, called me to his office and said, Barry, fix this. Get you a team together and fix it. So that's what I did. I got a team together and we set out to fix it. And so I gathered up designers and construction folks and central office folks, local folks, geotech folks, and we set out to finish it or to fix this problem, get it to the contract, because remember, the governor loves Tuscaloosa and wants to see this project built. And so we started out with, okay, what do we have? What are the tools we have available to us? And I said, all right, we've got the revised universal soil loss equation. We know if we reduce the area of disturbance and the duration of disturbance, we can get closer to winning on this. We can reduce the mass of sediment that's trying to leave our project. We had the 5 pillars of construction stormwater management available to us, except we really didn't have 3 of them. You remember that picture of the median area. There's not a good way to manage sediment. There's not a good way to manage erosion, really not a good way to manage water in that setting. You're working from edge of pavement to edge of pavement. How do you do it? So we had managing communication and managing work on our side. And fortunately, those 2 pillars are more effective than the others to begin with. So we started out in a good way by managing, bringing that team together was part of managing communication. I brought the river keepers in and I said, look, and our regulator also, I said, look, we're going to try some things on this project that we've never done before and you've never seen before, but here's where our heart at is, here's what we're committed to, and I need you to trust us to get this project underway and just watch. We'll give you tours of the project. We'll bring you out. We'll do whatever we need to do to keep you engaged in this project. And so those were kind of the ways we managed communication with our contractor. We told our contractor through plan notes and a pre-bid meeting, mandatory pre-bid meeting, that, well, I'll say what we told him. This is what we did. We went from vegetated to strip to excavated to covered in about 3 steps and within the same day. So let's look at that again. We stripped, cut, and covered really in one operation. So we told our contractor, at the end of the day, this project has to be covered up. We don't want to see any disturbed soil at the end of the day, and certainly not before a rain event. Everything gets covered up, and we gave them the tools they needed. We gave them an extra pay item of crushed aggregate. We gave them a pay item of polyethylene sheeting, and we said, stabilize this project before you go home in the afternoon. If rain's coming, then you stabilize it then. And so what we did is we went from 60 acres of potential disturbance to about 1/3 of an acre of potential disturbance. We went from 8 to 10 months of duration down to just a few hours of disturbance. And so thinking in terms of sediment loss and applying the Russell equation here, we reduced the sediment yield by over 99% because we dropped the acreage down, the area of duration, and the area of disturbance and the duration of disturbance down simply by doing our strip, cut, and cover technique. And I'll show you more in just a second. So once we were there, we can move on down the road. We could get our drainage in, our crushed aggregate in, and here's what our whole site looked like. This is all the activity going on the site on a given day. I'm standing on undisturbed grass, solid vegetation behind me, looking at our work area, and then beyond that, stable crushed aggregate base the rest of the project. So looking back the other way, and by the way, look at that truck traffic, 45% trucks on this road. So looking back the other way, this is me standing on the crushed aggregate base, looking beyond the work area at grass as far as you can see. So compare these two work areas, the way we used to do it versus the way we did it on this project. Look at drainage installation, the way we used to do it in the upper left. On the right there, we're excavating into clean material. We're sitting on clean material. We're backfilling with clean material. And so again, once we got the area covered up with aggregate, we really didn't have any potential erosion coming about. Our sediment control really went to gravel control, which is a much more manageable proposition, by the way. And so, so you can see what some of our inlets look like there. So I want to get to your questions quickly, but I have a couple of questions that I know that you have. I want to get these out of the way. So John, I'll walk through some questions on my own that I know they're going to have, and then we'll line up. So you guys be thinking of questions you have also. So as we're gathering this group together to try to come up with a solution for this project, the number one question our designers ask, which is a question that has bugged me for most of my career, is, hey Barry, we can't dictate the contractor's means and methods, can we? And my response is, why in the world can we not? You know, we're paying the bill, we're writing the check. The contractor works for us. We know that the contractor has different interests than we do. Sometimes our interests are in alignment, but sometimes they're not. We've got to protect our interests. We have expertise where they don't. So if we know that something is going to work, if we know that something's not going to work for us, why in the world would we not dictate those means and methods? And so the limit there, the drawback to dictating a contractor's means and methods is you limit their ability to be innovative. You limit their ability to save money, which sometimes does come back to the DOT. But where we know something needs to happen, we need to dictate that. So another question and this was really my fear from early on, was, man, we're going to slow production down tremendously, and it's going to take the contractor 10 times as long to build this project if we pursue this approach to managing construction stormwater. And I was actually wrong. I visited the project several times, and And I would ask the contractor, hey, how you doing out here? What do you think about this alternative approach to managing construction stormwater? And the superintendent would say, you know, unless it's raining, unless there's rain falling out of the sky, we're working. And that's different than in the past, because in the past we had this dirt bathtub that would fill up with water and mud, and we'd have to let that thing dry out for weeks on end. He said that we would have never started this project in November as we did. We would have waited until April to start this project. We would not be shifting traffic today on the day that I happen to be out there. I asked the contractor, okay, you're talking about all these increases in production and things that have helped you. I actually called together a debriefing meeting toward the end of the project with the contractor, with all the folks that we had on the team, our project inspection and management staff, and I asked these questions, and I just asked the contractor point blank, how much, give me a number, how did this help you with your production? And he said production was increased by at least 35%. And I heard him tell a construction engineer on his way out later, it had to have been more than 35%. Barry caught me cold. And so we know that production was increased. So a big question you might be asking, you see that we're, in essence, we're replacing dirt with rock. So our fill material, our cover-up material was aggregate. That's got to be expensive. And you're asking how much did it cost? And so I asked our division staff to do an analysis and give me back some feedback. And they didn't do a great job. And honestly, AlDOT doesn't do a good job of looking back to see how we did, whether it was success or not. We don't do a good job of quantifying that. And it's probably because there's so many variables at stake. So on this project, I asked that a cost analysis be done. There were significant costs above what it would have cost. It was about $500,000 on top of the contract cost. But we started looking at some of the other costs or benefits to the project. This project had two state troopers, law enforcement on site at about $18,000 a week. So if we saved 6 weeks, that's $100,000. We know that the FHWA calculated cost per mile, or the travel cost based on the delays. And the delays, we reduced the speed limit from 70 down to 55. And so those numbers were $25,000 a day. So if we knocked off 30 days of the contract, that's $750,000 right there in travel costs based on delay. We know our contractor's production was increased. We know that translates to money back to the contractor, which sometimes translates to money back to AlDOT. We know that before this project ended, there was another contractor on another interstate in Alabama that heard about this different way of doing things. They submitted a value engineering proposal to do it on that project, and both the contractor and AlDOT saved money on that project also. And you know, the savings in headache. I didn't have to talk to a single reporter. I didn't have to talk to a single lawyer, which was kind of unusual for a big project during those days. And so the headache, maybe that's a benefit to me, but I think it's a benefit to AlDOT also. So I think when we talk about cost benefit analysis, we really do have to analyze both the cost and all the benefits. And I don't know if you really understand how big this is, or if you're as excited as I am about this approach. Judging by your faces, I'm guessing you are. I can't see really. But for a guy with an environmental vision, working in an organization with a transportation mission, this is huge. And I used to tell folks I would shoot for the trifecta. And I know that it doesn't mean what I think it means, but I would shoot for something if I was going to try to make organizational change, I would shoot for getting 3 wins. I wanted to get my environmental win, but I would try to find and couple that with at least 2 other wins that were directly related to our mission. And on this project, I hit the jackpot. We improved quality, we enhanced safety, we minimized traffic delays, we increased production, and we reduced cost. You know, and on top of that, beyond this project, we changed our culture. We changed the way we've always done it. And so I'm helping, you know, this is 5 years down the road, and I'm helping AlDOT with some projects down in Mobile, Alabama, and I'm seeing that AlDOT is still minimizing delay, minimizing disturbance, minimizing duration. This is a shot of a 6-lane highway, and the contractor's constructing it half at a time. The center line's over there by the porta potty. He's constructing the eastbound lanes, already got sod and topsoil and sod and vegetation going on one side, hasn't even cut the trees on the other side of the road. Another project here, you can see we've even got some asphalt and shoulders and median sodded. The contractor hasn't even cleared the remaining two miles of this project. Another shot, a similar shot, you can see we've got vegetation growing at the top of the slope, installed sod, topsoil being placed at the same time the ditch is still being excavated. And that's due to a contract requirement that says, contractor, you shall start your permanent stabilization efforts once you get 20 feet into this cut. So a lot of benefits there, a personal benefit here. John Wathen said he has never seen a better run road project by AlDOT on his blog, but then he reserved his right to hate us in the future, talking about a future project he calls the Boondoggle Expressway. So anyway, I'll take it. That was a win for me. So John, let's hear a couple of questions, and if you would just reserve me maybe 2 minutes at the end. I've got a quick story that I'll wrap up with after we answer questions. So what do you have?
Very good, Barry. Thank you so much for your presentation. Do have a few questions here. How much did seasonal weather play into your construction schedule?
Yeah, good question. Here in Alabama, we kind of laugh when we hear about other states having to time their construction season to coincide with their wet season. We don't have a wet season in Alabama. We don't have a dry season. It rains pretty much year round. Our driest months of the year are November and say October and November, but those are also in the middle of hurricane season. So even in our dry times of the year, and this year's been really special with hurricanes coming out of the Gulf, we can have and did have just a few weeks ago a 5-inch rain. The driest part of the year, a 5-inch rain on one of our construction sites. So really good question, but we just simply don't have wet seasons here. And again, the contractor said unless rain's falling out of the sky, he's working on this project.
Okay. If you dictate the contractor's means and methods, how do you protect the state/consultants from liability should these means and methods incur additional unforeseen costs?
Yeah, great question. And I think we have to be careful. That's another drawback. I mentioned the drawback of limiting the contractor's innovation, but if you tell the contractor to do it a certain way and it goes awry, they're going to be the first ones to let you know that, hey, I did it exactly like you told me to. And I think we need to think through that. I think we need to be mindful of the risk of dictating those means and methods. But one thing I don't think we've really been mindful of are the risks associated with not dictating the contractor's means and methods. You know, when we tell the contractor, hey, just go build us a road, you know, there are risks out there, and we mentioned some of them earlier, and you know, the fact that we don't have control over all of these variables that can sink us. So we've got to build ourselves some cushion, build ourselves some grace. And I think the reduction in regulatory risk and the risk of fines and those types of things and legal issues, I think if we're smart, if we do things that are truly the state of the practice, and I'm seeing DOTs, I'm working with DOTs today that are really thinking through what is the state of practice today and how can we best get that into our contracts to reduce our risk. I think that's there is a balance there, but a great question. Thank you.
Okay, I'm going to put a couple of questions together really because they're pertaining to the same thing. What was the total tonnage of aggregate? What did you use on the entire project? And was there any cost difference between soil and gravel cover?
Yeah, so I don't have that number available even in my Even if I could look it up, I wouldn't know where to go to look it up. It's certainly not in my old brain right now. There was a tremendous amount of aggregate placed on the project, additional aggregate, because, you know, as soon as we stripped, there was some compaction that went on, and then we put the cover down with some compaction. So a lot of aggregate. And actually, that's one of our project managers. He was a young project manager, and during that debriefing, he said, Barry, we've got to find a way to utilize the dirt that's coming off of this project. He was seeing this perfectly fine soil being hauled off while expensive rock was being hauled in. And we did make some changes to the next project to allow the contractor to utilize on-site material, but still at the end of the day, they had to have it stabilized with aggregate. So there were tremendous costs. And John, I apologize, I just forgot the second part of that question.
Any cost difference between soil and gravel cover, was that established?
It was established. I did know that at one point, but I don't know that now. But you can imagine it was expensive to haul off good dirt, bring in, haul in aggregate. It's expensive, even though that part of the state has pretty good access to quarries.
Correct, but the cost savings at the end pretty much validated that cost.
We think so, yes.
Okay, if you wanted to wrap up a couple things, and then I need to get back to the next session. Go ahead.
Okay, all right, really quickly. So I gave this presentation at the Transportation Research Board annual meeting in Washington, D.C., a pretty stuffy place with a lot of suits, a lot of researchers, a lot of academics, and a lot of boring presentations. And that was one of the reasons I kind of laughed at myself for bringing in this cartoon of a presentation that I had created. And I have some personal friends. They were professors at Auburn University. They were in the room when I gave the presentation, and I knew they were going to give me a hard time. So at the end, one of them said, hey, my 6-year-old daughter called, and she's looking for a unicorn in your next presentation. Another one said, yeah, you need a rainbow. And so in honor of those guys at Auburn, I've given this presentation. This is maybe the second time since that presentation. So in honor of those Auburn University professors, here's your unicorn and there's your rainbow. So folks, thank you very much for attending this session. I really appreciate it. I wish I could see your faces and talk with you at the end of the show and hang out for a little bit. But if there's anything I can offer you, if there are any questions you have related to that specific project or the 5 pillars approach, or however else you think I can help you to implement innovative construction stormwater management techniques for your programs, please don't hesitate to give me a call or shoot me an email. And John knows exactly where to get me. So thank you, John. I appreciate your help, and looking forward to talking to you again in the future.
Yeah, Barry, thanks so much for the presentation. And everybody, I thank you for attending. The next session begins at 10 a.m. Please return to the sessions tab and see the next breakout sessions. If you are experiencing any difficulties, please visit the info desk for assistance. And don't forget to stop by and check out the vendors during the break. And that ends our session. Thank you, everybody.